All right, so we have our definition of congruent, which was same size and same shape, and we have our definition of midpoint. Midpoint, I would like for you to draw a picture next to midpoint. Draw a segment, please. You cannot have a midpoint. It was a great question you asked, Holly. You cannot have a midpoint of a ray or a line because they go indefinitely, but you can have a middle, a point in the middle of a segment. So let's say if this is A and this is B, then your very center point is M for midpoint. Okay. Now, if it's exactly in the middle, let's say that's 10 units long. What did it just do to those segments?
It halves them.
Yes. So a midpoint will cut something in half. I'm just going to use fives as an example. And I'm going to use this little tick mark here just to remind you that I think you've seen those before, but when you have a little tick mark on a segment that looks like this, that means they're congruent pieces. So from A to M and M to B is congruent piece. Okay, so I'm going to pause right there on the word midpoint, and I'm going to go to the midpoint theorem, which you glued in on that yellow page.
Oh, we did.
You did. And midpoint theorem, here it is, says exactly that. If M is the midpoint of AB, then AM, like we had drawn in our picture, equals MB. It will always tell you that this half and this half are the same size. Okay, so that is now a theorem form that has been proven to be true every time. Midpoint theorem lets you do that. Okay, we'll come back to distance. Okay, distance is a length between two objects. I could measure the distance from me to you with a tape measure because it's like a segment. You could just go straight to it. And that brings up a good point. Being straight to something is a distance. So like traveling from here to Abilene is actually, you have to do some curves in there.
It's like as the crow flies.
Yes. So the actual distance is as the crow flies. It would be straight to something. So if I wanted to know the distance from this point to that line, I do not draw any diagonals. I draw straight to it. My distance would be a straight path. Okay.
So, what is the term for that squiggly direction to Abilene? Route. It's the route.
Yeah, it's not really a good word for distance. It's just how far on the roads that you can travel.
Okay.
So, I don't know. It's not a geometric term. Put it that way. Okay. So just thinking in general, if you travel 30 miles and then you go 50 more miles and you want to know what your extra distance was, what would you do with that 30 and 50 to find distance?
Subtract.
Yes. So in general, to find a distance, this is a subtraction. You might add this just to remember, particularly on a number line is what we're doing today. Subtract the largest or the big, that's B-I-G, big number minus the small number. The largest number minus the small number, and you have your distance. Distance is never measured in a negative, and so you have these little symbols. You get I should make that a D. You get your distance. Whatever you get, if you subtract and wind up with a negative value, there's not actually a negative distance. You don't put a car in reverse and the miles come off of your car. They still add miles. So distance is always a positive. Do y'all remember the absolute value symbols? Mm-hmm. Anything that's in there?
Wait, so
comes out as
if you subtract the big from the small, how would you get a negative?
You shouldn't. But sometimes people will just subtract the two numbers, like 30 minus 50, and you get a negative 20. So that's negative 20 is not your distance. So 20 is your distance. So if you always subtract the largest minus the smallest, then you'll have a positive number.
Okay.
Okay. Even on a number line, so I'm going to do a quick example number line between the point -2 and here's 0 and here's 9. So let's say I want AB. And if it's a distance and a number length I'm looking for, I don't actually put a segment bar above the AB. I'm using an equal sign. It's wanting to know the length, so it's an equal value to something. So I would take my largest number of 9, my smallest number of -2, and I would subtract -2. And subtracting a negative becomes
it's like
adding. So my distance of AB is 11.
Okay. Neato.
So that's number line. We get into two-dimensional distances coming later, but today it's all about one-dimensional. All right, so a bisector is my next term. Bisector, what's the prefix?
Bi.
And then what's that mean?
Two.
Bicycle, 2 wheels. bicentennial, 200 years, things like that.
Wow.
That was an
I was trying to think of
unexpected
another
jump.
byword. Okay, bisector cuts in half. I want you to add to that, makes two equal parts. A bisector will cut something in half and make two equal parts, exactly like what a midpoint does. A midpoint is a segment bisector. It cuts the segment into two equal parts. Another segment bisector can be a line or a plane. So just here's an example of that. Here's my segment. Something that will cut it in half can be a point right there in the middle. If it's in the middle, then you would have tick marks on both sides to show that that's congruent here and here. You could have a line. It doesn't have to go at a 90 degree. If it went through the middle, then that line could be a bisector of that segment. Or you could even have a plane, if I had drawn that good, a plane that's cutting through that segment, okay? So you can have a segment bisector that is a point or a line or a plane. Questions? That's our vocab. Now here are the ideas behind today's assignment, besides finding distance and, how to find midpoint. I nearly forgot. How to find a midpoint. Let's use a quick example with this line here. Again, I'm gonna go back to the number line.
Wouldn't you just half it?
After doing what?
Finding the average.
Yes. You are simply going to find an average. The middle point between these two is what you get when you add the two numbers and then divide by 2. So a midpoint, as far as the number line goes, is just an average. So if I want the midpoint of MS, okay, midpoint of MS, and I abbreviate midpoint like this. I just leave out the vowels and the N, I guess. So MS's midpoint is 6 plus -3. I'm going to average, so I'm going to divide by 2. And 6 and -3 makes?
A number.
3. Divided by 2.
It's just
3 cut in half? 1.5. You can leave it 3/2 if you want to. Or 1 1/2. Any of those answers. I accept fractions reduced, improper, or decimals. Okay. All right, so that's all there is to find a midpoint. It's just an average. Take your two numbers, divide by 2 if you're on a number line. Okay, here's how we pull in a little bit of algebra. We're going to use the idea of those segments. And we're going to look at this segment addition postulate. All right, so segment addition postulate, I'm going to do with some numbers first, and then I'm going to change it to letters. Segment addition postulate, if it happens if A, B, and C are collinear. Tyson, what's collinear again?
They're on the same line.
Yes. So if there are 3 points on the same line, B is between, it didn't say middle or midpoint, it's just somewhere in between A and C, then this fact is always true. The length of AB, let me just say it's 12 right now, plus BC, looks like 5 right now, I'm just making numbers up, will always equal the total of AC. So how long is AC?
17.
17. Okay, so you should be able to have any two numbers in a segment addition property and postulate problem and find the missing number. So if we took these two off and I turned that into 9 here and a y here, how would I find the y, Holly?
you would subtract. You would set up a. So you would subtract 9 from 17, and
Yes.
it would equal your y. So
And
in
you could
this
also
case,
set that up in a small algebra equation. If I were to substitute here, I would say my 9 plus my y has to equal 17. Therefore, yes, I am going to be subtracting to get y equals 8. Okay, so that's one way. And then another way, you can even go a little bit more algebraic, which there will be some on the homework, and they might say that x plus 7 is AB distance. BC is, matter of fact, can y'all write this one down real quick? Just draw the picture and label. And BC is x plus, I don't know, 3. And AC is 3x minus 5. And we want to find the x, and we want to find out how long each thing is. So again, we can go back to our segment addition postulate and just kind of do a substitution. How long is this piece?
X plus 7.
We're going to substitute. Plus, how long is this piece?
X plus 3.
X plus 3 to equal the whole thing.
X3 minus
3x.
Or yeah.
3x minus 5. Okay, and you see how we made an equation? Now we have an algebra equation to solve, and this is where that kind of all comes together. So you have your 2x when you join like terms, plus 10 equals 3x minus 5. Bring your 10, now I'm going to take my 2x over here, subtract it. I'm going to add my 5 over here. So I get my answer for x.
Okay.
Okay, y'all with me on solving that?
Yes,
But
we
then
know
do you
it.
have to plug it in?
Now, it depends on what that's asking. I asked for the value of x, which is one of my answers, and then I asked for what are the distances, what are the lengths. So yes, we're going to go back and plug in. 15 plus 7.
Is a number.
22.
Is 22. 15 plus 3
It's
18, and then we want AC length, and you can either plug it in or you can add.
Oh, yeah.
40.
It's 40. Okay. So we found our value for x, and then we did our substitution and found the values. Yay. Okay, that's all for today.
Well then.
Lovely.
Thank you.
Good stuff.